Hi guys, well this is all very exciting. I'm pretty sure this is the very last video that I'll be talking at you for. And I'm excited for you because you won't have to listen to me anymore, and also because I'm hoping that you'll go and be able to go find a job, or at least start looking for one. So you can see my whole desktop today. Maybe after this video I'll have time to tidy it up. And the things that we're doing today are pretty cool, but maybe a little strange. Let me start by writing some words. Okay, so we're going to be learning about two things, abstract classes and interfaces. And these kind of go together because I guess they have a similar sort of purpose. Sometimes you have to choose between them. Oh, and it's a common interview question to be asked the difference between these, so that's why I'm going to talk about them a little bit. So to start, an abstract class, well, it's a kind of an ethereal thing that might not have bodies to its methods. You can't instantiate it. That means you can't say new and then whatever the name of my abstract class is. But it can have stuff in there. It can have member variables, and it can have methods, and it can have abstract methods. I'm going to show you those in a moment. First, I want to kind of get a sort of general overview of these two things. You subclass it with the extends keyword, which I know you're familiar with from the last lesson. And interfaces, well, interfaces are kind of more like, they're kind of like a programming contract, or sort of like a promise. This is probably a little better. It's a promise to fulfill some functionality. And with these guys, you implement them. And that will be a new thing for us, because actually an interface is not a class. It is a whole new thing. See here in the plus, we have different stuff. We can have JUnit test cases. We can have interfaces. We're going to be doing that. And you implement an interface using the implements keyword. That's not obvious. And so interfaces are not really like they're not a real object. They're more like an ability. So I'm going to go have a look at some examples. I think the first thing I'm going to show you is an interface. So let's actually just go ahead and do that. Okay, I'm going to make, an interface from my drop down here. And I'm going to call it Huggable. Huggable is going to have the ability to hug. Maybe I should have typed this out just so that you could see what's happening. So this is normal. And this is not normal. Usually we have that there, class, but now we have interface. So we're talking about a different kind of thing. This is not an object. Okay, so Huggable is going to have the ability. People who are huggable are going to have the ability to hug. So I'm going to talk like this. And I'm going to add a method that's for giving hugs. OMG, what did she just do there? That doesn't look like a method. It's not a method, it's part of the interface, and now I know that anything that implements this interface will have to implement this method, give hugs. I'm going to show you that. But look what's really peculiar here. This isn't like a regular method at all. It's just got a semicolon there. I'm just saying that you're going to need to have this method. So I'm going to go and implement it now with a class. That's me. Okay. Alright, so because I'm implementing Huggable, I'm just going to take this out for a second to show you that it's not red. That's fine. You're allowed to put a class once it's not public inside of an interface. But I'm going red here, that's me, June, because I have not implemented the methods that are in Huggable. So what this is saying is you must, if you implement this interface, you must implement the give hugs method. So I can do that by typing it out, but you know I very rarely do that, so I'm just going to add it in like that. All right, so here you go. It's like telling you that it's overriding this interface, and here is an actual, real, meaty, method-looking method. So in here, I would give the best hugs. That's my version. Okay, so that's an interface, and I've implemented it. I'm just going to show you that you could actually have more of these. What else should I have? Let's have an interface quotable. And to be quotable, you need to say something funny. Okay, so I could actually implement more than one interface. Look at all these talents that I have, quotable and huggable. I'm going to type it out this time just for kicks. Okay, and here's where I would put the meat of my method. Method meat. Alright, that is the basics of how the keywords and stuff work, and there are interfaces everywhere. So in the Java language, there's tons of these. And one thing that we've seen before is in list. There's a list. List is an interface, because when we're doing things like, I wonder if I did this before, the snakes on the plane business, maybe we did it like that. But so we usually have, when we're declaring an array list of objects, you usually do it like that, and then you're saying new array list. No space. Why are you being mean today? Alright, so something like that. Oh, I think I have my finger on the wrong key. Sometimes I get confused switching over between Linux and Mac. Okay, just come on now. Alright, so what I want to tell you is that this list over here, that's a java.awt list, and we're going to take a look at that now, is actually an interface. Alright, so I want to look up the Java doc, not that guy's opinion on things, which I'm sure is actually pretty legit. Okay, so here we have interface list, and you can have all different kinds of lists. Here's some examples of ones that actually exist in the Java language. And this is a pretty hefty interface. If you wanted to implement it, you would have to implement all of these methods. So this is like adding things to the list, adding a whole bunch of things to the list, checking what's equals, etc. So let's see what it would look like if I was actually to implement it. I'm going to make a class, Spoon. My nickname on the internet is June Spoon. That's why I'm calling it Spoon List. And I'm going to implement just regular old list. Implements. And then I'm going to import that eventually. Okay, Java utilist, and then Spoon List has gone red because I need to implement these things now. So I pretty much need to have a method body for each of these things. But guess what? I'm not going to be typing that out. Whoo! Look at that. Gnarly. Add on implemented methods. Okay, so if I wanted to make my own list, I'd have a little bit of work to do. Okay, next I want to talk about abstract a little bit. So abstract class is like a regular object that you can't instantiate. Honestly, I don't use these very much, so I'm just going to make, because I think they're kind of ethereal, they're not like real objects, so I'm going to use a ghost as an example. And I'm going to make, ghosts that can have a name because they still have the same name after they die. And then let's say that, well, they know how to speak. Yeah, that's not that crazy. Say boo. That's a method. Okay, so say I wanted to do, I didn't want it to be able to walk. Sorry, this example is just, I find it hard to really, look for things that are abstract or to use abstract classes. But anyway, so here I've got this method that has no meat in it. Ooh, do you see the option that I was given? See, it says add body, or I can change this method to abstract. So it's abstract now. And then the other thing is that it went red up here because if you have any abstract methods in a class, you also need to make that class abstract. Okay, so what I want to show you is that there is a difference between the abstract class and the interface, because if I was to make this an interface, then you wouldn't need this keyword. But it's gotten all, oops, so I actually want to just switch that for an interface. And then I wouldn't need this keyword for my walk method, because that would be a normal thing to see in an interface. But can you see that the member variable and the implemented concrete method have gone red, and that's because you're not allowed to do that in an interface. So really the difference is, if you have an abstract class, you can have stuff in there that can be inherited by the subclasses. And subclassing is really important because that's really how you use these abstract classes. So if you wanted to have some meat that you want to inherit, then you would use an abstract class. Otherwise you'd use an interface. This is kind of bugging me. Actually, I just want to make it back into an abstract class, ghost. By the way, the opposite of abstract is concrete. Pretty much everything we've been doing so far is concrete, so that's why you haven't heard the word. So, abstract classes, to be honest, I don't use these a whole bunch. Because interfaces are amazing and beautiful, and they are way more flexible and less tightly coupled. And abstract, yeah, I mean, you need to know it for interviews, I guess. So you definitely should brush up on stuff like when you should use abstract or interfaces, because they might ask you this in your interview next week. Let's see if there's any good answers here. When would you want to use that? Blah, blah. No. Abstract class can have shared state or functionality. Shared state or functionality, so it can have the member variable shared, or it could have actual functionality shared. An interface is only a promise to provide the state or functionality. Ooh, nice. I like this. A good abstract class will reduce the amount of code that has to be rewritten because its functionality or state can be shared. Alright, that's a really quick introduction, and actually the book is pretty good on this, so you'll see that the reading is not optional this week. I definitely think you should go in there. It's not a long chapter. Check it out. Then write to me and tell me how much better my way of teaching is, and all it will be forgiven. So the original, I think the first edition of the Deetle and Deetle book was the one that I used in college to learn. And I actually got it signed by Gabriel Byrne, the actor, on Grafton Street. But to be honest, I find it a little dense, and the language seems a little overly difficult, but that's just my opinion. Maybe you guys like that stuff. Anyway, I'm huggable and quotable. This list needs to go away because we don't want to have those red things. And so speaking of your first job, this is your exercise for this particular part. All right, so I have a class. This is a job candidate that has personality traits, hours spent coding, teacher name, and salary required. And we're going to try and tell which job candidate is better. And you're going to do that using the comparable interface. Let's have a look at comparable. Comparable is one of the pretty cool ones. I'm a fan. Now, see, look at all of the things that implement comparable a lot, and definitely stuff that regular old people write that aren't James Gosling. So it's an interface, and it forces you to implement one method, compare to. Now, this method is a little complicated to get to figure out for the first time, but I'm going to leave that puzzle up to you guys because you're proper Java programmers now. But here's kind of the key to it. So you're going to use this compare to. You'll have an object before it with a dot, and then compare to, and then you'll be passing another object into the parentheses there. And then you have to make your compare to method return a negative integer if the object is less than, or 0 if it's equal to, or positive integer if it's greater than. Alright, I'm going to leave it there because half the fun of this stuff is figuring this particular exercise out. But I'm just going to show you a little more about the task. This is a job candidate. You're going to be implementing comparable to add a compare to method. I'm just going to mess around in here for a second. So to compare, we're going to have at least 2 job candidates. So I'm going to volunteer to be the first one. Alright, so I've got to put in all this stuff. Personality traits. I'm not going to, so I'm not sure if I showed you this before, but you can do, arrays.asList, and then that lets you put an array, an old school array directly in here, so I can put strings in there, and hopefully you remember this from chapter 6, lesson 6, and then I can just put my strings right in here. I'm going to be adaptable. Definitely bad at spelling. Scatty, and you can never tell by my desktop. Curious. Those are my personality traits. I'm just going to put in 3. You see this? This is going to make an array list, so I can go in here. This is going to make a list of strings. And if I didn't do it like that, I'd have to, initialize an array list. Then I'd have to individually add each personality trait. Here I'm just doing it in this one little piece right there. That's how we would do. You could refactor this out if it's not that clear. Let's just do that. June's personality traits. Okay, so that just put that on an extra line, so it's got a little, it's a little more readable. Okay, hours spent coding. I don't know. My teacher was Vinnie Wade. Salary. Mucho. Okay, so you guys are going to have to figure out how you would choose one job candidate over another, and you've got a few different options in there. So I think I want to leave you to it. There was one little thing that I want to show you, which is that for interfaces, they have their own UML. Let's see if I can show you. Wow, interface UML. Okay, so yes, here's one. So the arrow that you use for implements has got this broken line that's different to here. This one is for extending. Actually, this is quite a nice example. So here in the UML, you'd call an interface by putting those crocodile teeth either side, and it's always got this italic. And then you have an abstract ball class and a rock that implement tossable. How do I know that ball is abstract? Because I can see that it is in italic. So ball's abstract, and so are the toss and bounce methods in here. And I can see why they did that, because then they have other balls that actually extend the abstract ball class. Yeah, this is a nice example. Also, check the book. The book's got a nice example that looks kind of real worldish. So there's how you do UML for interfaces. Here's another one. This frame implements that IEV service, and share does too. So I know by looking at this that both frame and share would need to implement this get service name method. Okay, I think that's all for now. Ooh, maybe I feel a little sad. But I'm sure you'll be glad not to be listening to me every week. And congratulations if you've actually gotten this far, because that is no mean feat, and you're awesome. Okay, over and out.